Okay, here on the left I've got four vector equations of lines. It might not be immediately obvious, but in fact some of those are the same line. And we can think about this first of all to recap a 2D Cartesian form of a line. Something like y equals 4x plus 7 is the same as y take 7 is 4x. It's the same as nothing is 4x take y plus 7. It's the same as 3y plus 12x, equals 12x plus 21. There's lots of things that look different but are in fact the same and can be rearranged. So we're going to look at some ways of checking that information out of this form of the equation. So we're done with that for now. So are any of these lines the same line? So a line has two properties, a place and a direction. To start with, let's look at the directions. So if the lines are the same, they must be parallel, right? Because if they're not parallel, they're clearly not the same line. So this here has that direction vector. This looks very similar. The two matches, but these two have been swapped. So we can rule this out straight away because there's nothing you can multiply this by to get that. So that is not parallel with that. So those two are not equal to each other. So is this equal to one of those two? Now it looks to me like this vector is negative 2 times that vector. Negative 2 multiplied by 2, negative 1, 1 is negative 4, negative 2, negative 4, positive 2, 2, negative 2, which is that. So this is parallel to that. So it looks like they might be a pair. And this looks like it's 4 times that. So that is definitely ruled out by the gradient. That gradient already means it can't be the same as these three. So how can you know if these three are the same line? Well, there's two cases now. We've either got parallel lines like so, or we've got parallel lines that in fact are in the same place, which means that they share points. So, is it possible that any of these share points? So, let's look at R1. In the x component, the x value is negative 1 plus 2 kappa. Right? Now, if R1 is the same as R3, we can get to R3. We can get to this point here in those steps. So let's just check that out. This is 3, we're going to get to 3. 3 is negative 1 plus 2 kappa, add 1 to both sides, 4 is 2 kappa, so 2 is kappa. So what happens if I use that here? Well, in the y values we get 1 from this R3 is 3 plus kappa, which we've worked out is 2, lots of negative 1. While 1 is 3, take away 2, 1 is 1. Well, that works, so it looks like we can get the y value to work. So what about the z value? So we're going to get negative 6 is 2, because it's the same kappa. What am I talking about? That is just wrong. Apologies. For the z value, we're trying to get to negative 4, which we're going to get to by doing negative 6 plus kappa, which is 2, lots of the z value 1. So that's negative 6 plus 2, which is negative 4, and that's also true. So we can get to this coordinate here by doing 2 of those steps. So 2 of those steps get us there. So that means that these two lines are in fact the same line in a different form. In a similar way, we can check this out, and this actually won't be the same. So to get from 3 to 7 is a step of 4, which is negative 1 lots of this. To get from 1 to 1 though is no step at all, so that means this would have to be 0. So we've got these two being different from each other, so we don't need to check z. There's no way to get from there to there in this direction. Alright, so that's an important thing to check, is have you actually got a different line, or are these lines the same? Enjoy!